Hello, everyone. Welcome back. Let's continue this chapter 2, section 2.2. So section 2.2 is about frequency distributions and their graphs. It's more for the quantitative data. So for quantitative data, it's common that we see that the range of the data is large and the data must be grouped into classes that are more than 1 unit in width. So that is called a grouped frequency distributions. So we're going to introduce two types of data set that we can work with. So let's see the first example, data set 1. So we can have some quantitative data set like this. Number of TV sets in each of 50 randomly selected households. So we have 0, that means no TV, and then 1, 2, 3. So the maximum in this data set is 6. So 0, 1, 2, 3, 4, 5, 6. We have 7 distinct values. So for this type of data set, it's kind of easy to put those in classes just by different values, because the number of different values is only 7, not a lot. So it's still we can still just classify those that way. And then data set 2. So this is for weights of 13 males age 18 to 24. So if we look at this data set, we have almost all different values, 13 different values. So if we still use the same method we proposed for data set 1, we're gonna just encounter a problem, because we're gonna have each value stand for its own class, and then each class we just have one value. So basically we didn't organize anything, and then if there's no improvement, then that way just doesn't make any sense. So we're gonna just choose a proper grouping method to properly organize these two type of data sets. So now, before we talk about the grouping methods, let's look at some basic requirement for organizing quantitative data. So we're first going to group the observations into classes. So the guideline 1, the number of classes should be small enough to provide an effective summary, but large enough to display the relevant characteristics of the data. Usually we choose 5 to 20. So this is more like a standard 5 to 20. But for practice problems, this is going to be given. These classes will be given. The reason we say we want to have a reasonable number of classes is because if let's say we have 50 numbers in a data set, if we want to use 50 classes, then pretty much we're going to have one value for each class. Then we don't have any grouping that we put into the organizing. So just doesn't make sense. Or if we just choose 2 classes, so maybe we're gonna have one class 21 numbers, and then another class 29 numbers, then still doesn't make sense. So we don't see the distributed of the whole data set. So we cannot visually say it as well. So 5 to 20 is reasonable. And then number 2 must be exhaustive and mutually exclusive. So now let's see what is exhaustive. So exhaustive mean that when we generate the classes, we want it to be seamless, so that for every single value in the data set, we can find a space to put the value in. So if we look at this one, that's a violation of exhaustive. We don't have the class for number 5. So when we look at the data set, whenever we see number 5, we don't know where to put it. So that is a problem. And then we want to make sure it's mutually exclusive. So what is the violation for mutually exclusive? So now let's see the second example here. So if we have 0, 1, 2, 2, 4, 5, 6. So we have two classes that have an overlap. Then the problem is when we see number 2, we don't know which one to put the value in. So that case, we call it a violation of mutually exclusive. So this is also very important. Must be exhaustive and mutually exclusive. And then the third one must have equal length, the same width. We don't want one class that you can store 90% of the data, and then for another class only suit for another range of 10%. Then although you can show some information, but that may not be the most accurate one. So number one, number of classes should be small enough to provide an efficient summary, but large enough to display the relative characteristics of the data. Number 2 must be exhaustive and mutually exclusive. Number 3 must have equal length. And after we discuss that, we can look at the grouping method. So basically, we are gonna introduce just two grouping methods based on the property of the data set. So the first one, we call it single value grouping. So when to use that with discrete data in which there are only a small number of distinct values. So let's go back to data set 1, discrete data, because they're all integers, count for TV sets. And then we only have 7 different distinct values. So of course, for data set 1, we're going to choose single value grouping. And then for data set 2, we're going to use cut point grouping method. We're going to use that when the data set are expressed as whole numbers and there are too many distinct values to employ single value grouping, or when the data set are continuous and are expressed with decimals. So no matter which one, cut point grouping going to be suitable for that. So let's go back to data set 2. So values with decimals, we have to, and continuous. So we have to use cut point grouping method. So now let's see how to apply those two different type of grouping method. For data set 1, the class is gonna be just the distinct values, and then we're gonna start with 0, and then just put it in an increasing order, 0, 1, 2, 3, 4, 5, 6, and then we're gonna count how many numbers we have for 0, and then for 1, for 2, for 3, for 4, for 5, and for 6. So this is very similar to the categorical or qualitative one. For that one, you still have different categories. And then just naturally, you have different groups. And then for the data set 1, after we count, we have this frequency and then relative frequency. The single value grouping method is pretty straightforward. And then for the cut point grouping method, we have certain steps to do that. So now let's look at data set 2 again. We have 13 numbers with decimals, they're continuous. And then we're gonna do this cut point grouping method. So step 1, we're gonna rank the data from the smallest to the largest. Rank the data from the smallest to the largest. Now let's write down. So we have I think it's already properly ranked. So 129.2 up to 278.8. So this step is checked. And then step 2, we're going to choose the desired number of classes, usually between 5 to 20 or given from the problem. Usually it is given from the problem. And know that there's the proper number of class only. The exact one might be changed. So proposed. So what is the proposed means? So when we look at the width, we're going to choose a way to calculate the width. and then that is a number, most likely it's going to be a number of decimals, with decimals. And then you want to round it to a reasonable numbers that is easier for you class the group. And for the classes, as long as it's reasonable and makes sense, well, we don't need to have that to be exact. So now let's just try to use dataset to see how to finish these 7 steps. So step 2. So 5 to 20, and since we only have 13 numbers, it's a really small data set. So we probably just gonna choose 4. And then we're gonna calculate the range. Range equals maximum minus the minimum. So that's a formula. Maximum is the largest number and minimum is the smallest number. So we're gonna say range equals, the largest number we have is 278.8 minus 129.2. And then that is let's see the correct answer for this one. 278.8 minus 129.2, 149.6. And then we're going to calculate the width, like we mentioned. So width equals range divided by number of classes. So 149.6 divided by 4. So this number 4 is the proposed number of classes. So you think 4 is reasonable for these size of sample. So size means how many numbers you have for your sample. We only have 13 numbers, which is very small. So although usually it's between 5 to 20, we're just gonna even lower one more class to make it reasonable. So 4 is the proposed one. But really, how many classes we got for our groups is based on the final frequency distribution. So 149.6 divided by 4, so we got 37.4. 37.4. So this is the width. That means the difference between the lower class limit and upper class limit for each class. So for example, you can say I want to have a group, a class that includes numbers from 10 to 20, and then 20 to 30, 30 to 40, 40 to 50. So that 10 to 20 means the lower and upper limit for the class. And then we want to make that width equals with each other. And then now we start from the width, try to know what kind of classes we have. So 37.4, for example, if we start with a first class starting number is 10, then the upper limit for this class is going to be 47.4. And then the next one going to be still plus 47.4 still plus the same width, which is 37.4, which makes the calculation a little complicated. Then usually when we have the width, because for this grouping method, we finally we just want to have a visual way to see the data, what it looks like, how the data distributed. So a slightly different width won't affect that organizing or just describing the data. So we're just going to round up to 40, which can make the calculation easier. So now we're going to start with a starting point, which is the lowest value of the data set. So the smallest value we have is 1.129.2. And then step 6, we're going to find out all class limits until the last upper limit is greater than your maximum. And this is also important. You don't have to get the same number of classes as the proposed one. And then step 7, we're just gonna finish the count, the tally. What is the frequency? What is the relative frequency? So now let's see this result. So we're gonna start with 129.2, and then since we defined or we calculated our width is 40, so here we plus 40. And then to make the upper limit for the first class is 169.2. And then the second class, we start from 169.2, and then the upper limit gonna be plus 40 again. So that's 209.2, and so on and so forth. So we continue doing this. So plus 40 here, plus 40 here, plus 40, until the last class, the upper limit of the last class, 289.2, is more than the maximum, 278.8, then you're gonna stop. So this is more than the maximum, which is 278.8. But if you look at 249.2, you still don't have a place to store the largest number. So you still have to continue to include 289.2. So then we finish the grouping. So this way we call it cut point grouping. And then now you can just try to look at each number. So the first number, we have 129.2. So we're gonna put in the first class. 142.8 first class. The third one, 155.2, 161.0, and 165.0 and 169.1 is still under the first class. So we have a total of 6 numbers for the first class. So we put the frequency 6 here. And then the next one is 170.1, the second class, 170.5, the second class, 176.7, second class, 182, second class, 188.7, still second class. Then what about 209.2? 209.2. So you have 209.2 here as the second class as upper limit. You have 209.2 as the third class lower limit. So if we don't have this notation, then we're gonna have a problem. That's a violation of the mutually exclusive. You don't know where to put 209.2 in that case. But with this notation, problem solved. So this is called 2 but smaller than. So for the first class, the number that are going to be put in the first class is 129.2, 2 but smaller than 169.2. So up to this number, but not include this number in this class. So 169.2 is included in the second class. To a number up to 209.2, but not included. Then if we see 209.2, we know the second class is up to this number not include, then it is gonna be in the third class. So I have one value here and one value here. Then you may ask me another question. What about if we have a number 289.2? So if we have such a number, we need one more class because 289.2 is exclude from this class. If you have that number, you need to generate a new class just to put the number in. So now we just finished generating this frequency and relative frequency distribution using the cut grouping method. And then finally, you can check how many classes you have. You have 1, 2, 3, 4. You have a total of 4 classes. So now let's go back to the steps. So at beginning, you propose to have 4 number of classes, and then now at the end, you happen to have same 4 number of classes. So the result might not be exactly 4. For some future practice problem, you may see 5 or 3. It's all possible, but just going to be very close to the number of classes you proposed. And now let's talk about this cumulative frequency of a class. So for this part, it is very clear. We all know how we got this already. So it's frequency and relative frequency distribution. And now we're going to look at the cumulative and cumulative relative frequency. This is RF stands for relative frequency. So cumulative is just up to this class, what is the count. So for the first class, we have a frequency of 6. Then we have a cumulative frequency equals 6 as well, because up to this first class, we have only 6 number. And then now if we look at the second class, we have a count of 5. So cumulative frequency means up to the second class, how many numbers or values we have. So we have 6 for the first class, 5 for the second class. So then we have 6 plus 5 equals 11. So the cumulative frequency up to the second one is 11. So same thing for the third one. So from here, we have 1 new count for the third class. So use the previous 11 plus the 1 for the third class, we got 12. And then for the fours, up to the fours, we have 12 plus 1, which equals 13. So cumulative frequency is just the frequency up to this level. And then always the cumulative frequency for the very last class is the total. So this 13 is going to be same as the total count. And cumulative relative frequency is going to be very straightforward. Just use the number we have here divided by the total. So 6 over 13, 11 over 13, 12 over 13. And then this position is always going to be 1, because that the count here up to the very last class is always going to be the total. So total divided by total, always going to be 1. Okay, so after this cumulative frequency, let's talk about histogram. So a histogram is similar to the bar. A histogram to the quantitative frequency distribution is very similar to the bar chart to the qualitative frequency. So we just want to use bars to display the distribution of the value. So let's look at the number of TV data set, and then we can generate a histogram for this single value grouping. So like we mentioned before, so you still have different categories, numerical values, but the bars now they stay together because they're it is histogram now. And then for this cut grouping 1, we have 6511. So always when you generate histogram, you want to look at the frequency or the relative frequency. And then 6511, just remember that frequency. And then when you generate the frequency, the height going to be exactly same as you have in the distribution. So 6, 5, 1, 1, 6, 5, 1, 1. And then for the percentage, so relative frequency histogram using the percentage, 46.2, 38.5, 46, 46, and 35. So the bars should match whatever frequency or relative frequency we have in the histogram. So this is important. Okay, so now we finished section 2.2. We'll stop here for this video lecture, and then next one we're gonna start from section 2.3.